Okay, we're going to do, now we're on chapter 3, page 57, we're going to do E11. And it has to do with firing a bullet. You know, interesting, this is a projectile motion problem. When you're doing projectile motion, you know, it's like two separate problems because the bullet is traveling in one direction, but the force of gravity is also accelerating it down to Earth. And the force of gravity doesn't care if the bullet is moving, you know, in this direction or if it's standing still. So if the bullet is this high off the table and I let go, it's going to take, you know, that much time for it to hit. If I was, you know, if I had a rifle and it was this high off the ground and I shot the bullet straight, well, it's going to go, but it's going to hit the ground the same time, right? So gravity doesn't care that it's going this way or this way. It's pulling it down to the earth at the same rate. That is cool. So it's you're doing two different problems. You're solving how long does it take, you know, the bullet to fall vertically, you know, and usually that's a good way to get the time because you'll say, well, it took that much, and then how long does the bullet take to hit the target? Well, that's a separate problem. That depends on the velocity, the velocity that it's traveling, and then it's going and it hits whatever the target is, however far away it is. So it's two different problems, and that's important to realize. Okay. So we're going to do 11. So a bullet is fired horizontally. So what they're saying is that you know, the gun isn't pointed up or down. The gun is just pointed straight, you know, or horizontal with respect to the ground, and it shoots it horizontally. Okay. So E11. A bullet is fired horizontally with an initial velocity of 800 meters per second at a target located 200 meters from the rifle. How much time is required for the bullet to reach the target? Okay. So let's write down what we know. So the initial velocity out of the rifle is 800 meters per second, and this is and that's a horizontal velocity. The distance to the target is 200 meters, and what they're asking for is how much time is required for the bullet to reach the target. So T, we're looking for T, right? Well, we know that from our last chapter, velocity is equal to distance over time. So therefore, these three dots means therefore. If we solve for T, time, it's using algebra, solve for T, time is equal to distance divided by velocity. Okay? And in this case, that's going to be, your distance is 200 meters divided by 800 meters per second. Okay? And the meters cancel out, right? Units. And you divide 800 into 200 and you get 0.25 seconds for the bullet to hit the target. All right. Very good. Now, let me go like this so you can make sure you see it. Shadow. I don't have a studio here, folks. It's a fancy production studio, I know. Okay, let me move this over. And we're going to do the second half, so part B. So this is E11B. Let me move this over here. Can you see that? All right, I think that's better. E11B, okay. Using the approximate value of G equals 10 meters per second squared, how far does the bullet fall in this time? Okay, so we're looking for the height. I'll call it H. Okay, time, we know how long it took from the previous problem. The time is equal to 0.25 seconds, right? They're approximating G as 10 meters per second squared, the acceleration due to gravity at the surface of the Earth, right? And what they want to know is how far does the bullet fall in this time, right? Because it was shot horizontally. As soon as it comes out of the muzzle of the rifle, gravity is acting on it, and it's pulling it down. So the target, he may have been aiming at one spot, but it's going to be a little bit lower. You know, when they're doing target, when you see targets shooting in the Olympics or what have you, and they're shooting at targets, the guns are actually, the barrels are actually aimed up slightly. Now the scope, if they're using a scope or sights, it compensates for that. But the barrel's actually moved up, and in order for it to hit the target, if the target is at the same level, it has to travel in an arc, right? So, okay. So now let's go ahead. So we have G. So distance, we know from the previous chapter, is we have the formula 1/2 acceleration times time squared. Acceleration of gravity, that's G, equals 1/2 10 meters per second squared times 0.25 seconds squared. So that equals 10 meters per second squared times, and then you square 0.25 and you get 0.0625, and then inside the parentheses you get a second squared, right? Because you've squared that quantity, and divided by, because it's multiplied by 1/2, so divided by 2. Now equals, well, you have a second squared in the numerator here. You can cancel out the second squared in the denominator here. You're left with meters. So 10 times 0.0625 divided by 2, and you get 0.3125 meters. Okay. And that is how far the bullet dropped, how far it fell. All right.